So we already saw in order to create a table, we use the create table command and it's a DDL statement. So these are the create table statement looks like. It will be create table name, and then we will have the column names followed by the data types. And you already know what each of the data type is. Give me 2 minutes. In each and every RDBMS databases, each table will have a primary key, and that primary key will be used in order to uniquely identify a row in a table. So if you want to decide like for example, if you take a company, each and every employee will have an employee ID, and that employee ID will not be same for both the employees. In that case, it will be a primary key. So if you have any of the columns which can uniquely identify each and every row in a table, then we will define a primary key constraint on the table. So in order to define the primary key constraint while creating the table itself, we can define, for example, if I want to go for enum, I want to go for a primary key constraint. I want to have a primary key constraint on the enum. Then I will define a primary key constraint saying once after the column name and data type, I will say primary key space. I can give any name for a primary key. So I'll give it as audit underscore table underscore pk. This will be a primary key name. This will be a primary key constraint name. After that, we have to specify on which. That's it. This is how we will specify a primary key constraint while creating the table itself. If you want to add a primary key constraint on the existing table, we will use alter table statement. Even alter table is a DDL statement because it works on changing the structure of a table. Any statement which will change the structure of objects in the database, those statements are called as DDL statements. So if you want to define a primary key constraint on the existing table, this is how we will define a primary key constraint. Okay, once the primary key constraint is defined, if I'm gonna describe the EMP, if you see here, for now, okay, let me describe audit underscore table. Before, when I describe the audit underscore table, if you see here for enum, there is the null column doesn't show anything because there was no primary key constraint defined at that time. Once I defined the primary key constraint on that column, if you see on the null, it says as not null. That means whenever you define a primary key constraint for any of the column in a table, it cannot hold null values. You cannot insert a null value into the table for a column which has a primary key. Okay, first thing is primary key will uniquely identify each and every row in a table. The second thing is primary key cannot hold null values. For example, if I want to insert a row into the table, if I want to insert a row into the table, insert into add underscore table, I'll specify user underscore at, comma, time underscore now, values, user underscore at, I'll make it as 192.168.10.20, and then time underscore now, I'll make it as 2 underscore date of today's date, so 16/04/2013, DD MM. Okay, there is no need to have 2 underscore. Okay, 1 second. The maximum length I defined it for 10 digits. So let me make it as 1 into 16010. Just an example. So in the first case, it errored out because the maximum length it can hold will be 10 characters. The input value which I gave was more than 10 characters. So it errored out saying value too large for column. After that, I'm giving it with exact thing. But if I'm trying to insert a row into the table, if you see here, I defined a primary key constraint for this column enum. So it once I define a primary key constraint, as I said, it cannot hold null values. So if I'm not specifying the column which has a primary key in the column list, and if I'm trying to insert the values, it will try to insert a null value into the enum, which is not possible. So that is the reason why it will error out saying cannot insert null into the table. So if you have a primary key constraint defined on a column, whenever you are trying to insert a row into the table, you need to make sure that column is included in the column list. So I can insert a row into the table as enum and values. So this is how we'll insert a row into the table. If a table has a primary key constraint, we need to make sure the column is listed in the column clause. And if I'm trying to insert a duplicate value into the same row, for example, I'm inserting a second row, and I say 192.168.20, and I'll give the same date, and I'll give the same value. It will error out because whenever you define a primary key constraint on a column, it should have unique value. Each and every row, each and every column, each and every value, or each and every cell for that column should have a unique value. You cannot have duplicate values if the column has a primary key constraint. So that is the reason why it will not allow you to insert the same value. So primary key constraint means three. One is it uniquely identifies a row, it cannot hold null values, and the third is it should have unique values. Then not null constraint. For example, each and every employee in the company should have a manager. Okay, if that is the case, and if I have a manager column in the table, then I have to define a not null constraint, because as I said, each and every employee should have a manager. That means whenever I'm trying to insert a row regarding the employee information, and if I'm trying to insert a null value, it should not insert the null value into the manager column. In that case, or if that type of conditions I have to put on a table, I have to define a column with a not null constraint. So in this case, if I want to define a not null constraint on audit underscore table, for example, if I want to define not null constraint on time underscore now, then I'll go for alter table, audit underscore table, time underscore now, add constraint, constraint name I'll make it as audit underscore table underscore nk or nn, not null. But which column I have to make it as not null? I have to make it I have to define not null constraint on time underscore now. Okay. So if you want to define a not null constraint, the command will be alter table table name. After that, modify column time underscore now number or date space not null. One second. These are we can define a not null constraint on a table. So once we have an not null constraint on the table, it cannot hold null values. Now if I describe audit underscore table, if you see for the null column it says not null. That means it will not hold null values. So if you want to have a column in which null values should not be allowed, then you will define a not null constraint on that column. Then the third type of constraint is unique constraint. For example, if you want to store social security number of each and every employee, in that case social security number will be a unique value. Two employees will not, or two persons in US cannot have the same social security number. So if you are trying to insert or if you are trying to store social security numbers in a column, that type of columns you have to define a unique constraint such that whenever you are trying to insert the data, it will check the unique values and it will allow the user to insert the values. If the two employees are trying to insert with the same social security number, it will error out saying unique constraint violated. But you can ask me, what is the difference between a primary key and unique? Even in primary key, it will be uniquely, even it will hold only unique values. But the difference between a primary key and unique key is, if you define a unique constraint on a column, then it can hold null values too. But a primary key constraint column cannot hold null values. A unique constraint column can hold null values. The moment you come into the US, you will not have a social security number. So social security number is a good example of unique constraint. So you can, if you want to store social security numbers, you need to define a unique constraint. You need to add a constraint to the, you need to add unique constraint to the table.
One second. Mohan sir.
Mm-hmm.
You say unique key is like a same to primary key, right? But they allow the null value, correct?
Yes.
But like a 2 or 3 null value in a row, they are acceptable or not?
2 or 3 null values?
Yeah, like suppose first row have a null, right? Some key like user ID is a null.
Mm-hmm.
First three rows null is acceptable in unique value or not?
Yes, it is acceptable.
Acceptable, right?
Yes.
And a primary key not acceptable. This needs some value, correct?
Yes.
Oh, okay.
So for example, if I want to define a unique constraint on job column, I'll go ahead and define that using alter table, alt underscore table, add constraint, alt underscore table underscore unique. This will be constraint name. After that, we have to specify table name, which is alt underscore table, and on which column you want to specify the unique constraint. So I want to specify it on job column. Add constraint. Okay, I have a table called as emp underscore one. I'll define a unique constraint on this table. Okay, so looks like this is not the way to define a unique constraint. So it will be alter table emp underscore one. No, 1 second. We are correct, but the only thing is constraint name. After that, you have to specify the unique. So you're defining a unique constraint. So you have to specify it as unique. Table add constraint name. You okay? alter table emp underscore 1, add constraint emp underscore 1, unique. After that, what we have to give?
Column name.
Yes. ఏంది హిట్ రన్ చేసిరా? This is the way we'll add a unique constraint. I was adding the table name. Alter table, table name, add constraint, constraint name, after that constraint type and emp number. In the same way we added the primary key constraint also. So if you look at the primary key constraint, we did the same thing. Alter table, table name, add constraint, constraint name, after that constraint type, and then within the braces column name. In the same way we'll add the unique constraint. But the only difference between a primary key and a unique constraint is unique constraint can hold null values. For example, if I am trying to insert a row into emp underscore 1, I'll just give emp number and then values ampersand 1. Okay, so now I'll give the value as 10, one row will be inserted, then I will give the value as 20. So if you see here, two columns have null values, two rows have null values for emp underscore 1. For emp number, if you look at the emp number, I inserted 10 and 20 and ename is null, or sorry, on which column did I, sorry, I added a unique constraint on emp number. So let us go ahead and insert null values for emp number itself. So insert into emp underscore 1 space ename values. First I'll give it as Mohan. Then I'll give I'll try to insert another row. So it will accept the null values. Even it is a unique constraint. If you look at the two rows in the table, even though the column ename or emp number has null values, those doesn't mean the two values are same. Null is a different thing in Oracle. It treats it as a different value. So that is the reason why even both the rows it will accept null values. Okay, Girish? This is what you asked, right? Can two rows can have the null values or not? Hello.
I see here.
Okay. Clear, right? Unique constraint. Any doubts?
Yeah, good. I mean, no doubts.
Okay, now next we'll see about check constraint. As I said, for example, if I'm storing employee and the salary should be at least $1,000, then I'll go ahead and add a check constraint. So I'll do alter table emp, add constraint, constraint name I'll give it as emp underscore check, and then the constraint will be check. After that, salary greater than $1,000. So this will apply, or this will add a check constraint on the table emp. Okay, so if you see here, I'm not able to add that constraint. The reason is some of the employees in that table has salary less than $1,000. So let me make it as $500 for now. It will not allow me to alter the constraint. The reason is existing data, existing employees has salary less than 1,000. So whenever there is whenever there is data already exists in the table, you cannot add a constraint which doesn't satisfy the existing data. Now you can add that constraint. The reason is none of the employees have salary less than $500. So in this way we can add a check constraint. Okay, the last constraint will be a foreign key constraint. So in order to develop a relationship between two tables, then we will add a constraint called as foreign key constraint on a table. For example, if I take emp_1 and there is a table called as DEPT department number, DEPT department table. In this DEPT table, there is a column called as department number, and this is a primary key on the table. It has a primary key constraint on this column. Now on emp_1 table also I have a column called as department number. Now if I want to develop a relationship between these two tables, then I will add a foreign key constraint on this column department number of emp_1, which will refer to the department number column of department table. So in order to add a foreign key constraint, the command will be alter table emp_1 add constraint references department table of department number. This is the way we will add a foreign key constraint on a table. So the moment we add a foreign key constraint on the table, whenever you are trying to insert a row into emp_1, and if you are trying to insert a value into the department number which is not present in department table, then it will error out, because whatever the values you are trying to insert into emp_1, you need to make sure this department number value, it already exists in the department table. If it does not exist, it will error out saying foreign key constraint violated. Its references. So this is how we will add a foreign key constraint. Now if I select star from department, okay, if you see here in the department number column, I have 10 to 60 numbers. Now if I'm trying to insert a row into emp_1, ename, emp number, salary or department number, and if I'm trying to insert a value, and for department number, if I'm trying to insert 70, if you look at the department table, department number 70 does not exist in department table. So if that value, if I'm trying to insert into emp_1, it will error out. It says integrity constraint violated, parent key not found. So whenever you are trying to insert a row into the child table, you need to make sure the corresponding value exists in the parent table or not. Is it clear?
Yes, yeah.
So these are all the constraints we have in Oracle, the 5 constraints: primary key, unique key, not null, check, and foreign key constraints. So till now we saw how to create a permanent table. So whatever the table you created, it will exist permanently. So whether the server is down or not, once the server comes up again, for example, if you're shutting down the server and if you're bringing up the server again and if you're starting up the database, the table will be present in the database because it's a permanent table. It will exist until the database is up and running. There are some tables which you can create which are called as temporary tables. Those tables will exist depending upon how you create them. So you can have a temporary table exist for a session or for a transaction. Temporary tables. You can create a temporary table which can exist for a session or for a transaction. So transaction you already know. That means whenever you issue commit, rollback or any DDL statement is executed, that means a transaction is completed. Session means whenever you are trying to connect to the database. Once you connect to the database, for example, using SQL Plus, I connected to the database. Once I make a connection to the database, a session will be created in the database. So session is nothing but a connection. So a table will exist until I have the session. So once I get disconnect from the database, I will not have the content in the table. So as I said, it can be a session or for a transaction. That means data in the table. It's not the whole table. The table definition will be there. Table definition will be there forever. But data in the table can be either session specific or transaction specific. In order to create a temporary table, the statement will be create global temporary table, and then we will have the same thing like column name and data type. After that, the length of the column. So ename varchar2 of 10, emp number of 4. After that, you have to specify on commit preserve rows. If you want to create a table with session specific, that means the data in the table should be there until the session lasts. Then you will create a table using on commit preserve rows. If you want to go for a transaction specific temporary table, you will create that using on commit delete rows. So these are the two ways in which you can create a temporary table based upon your requirement. So when you create temporary table using on commit preserve rows, it will be there until your session lasts. So once you exit from the database, once the connection is lost, all the data in the table will be flushed. You'll not have the data in the table. So first, let me go ahead and create a transaction specific temporary table. On commit delete rows. So this will create a transaction specific table. Yeah, spelling is wrong. So if you look at this one, varchar2, I mistyped it. There was a typo for varchar2. So if I want to change that, I need to first highlight the line. If I do L, it will list the whole command. But if you want to change a specific line, if you want to use a C option, then you need to highlight the line where you want to change. Right now I want to change on line 3. So first I have to press 3 and then enter. This will highlight third line. After that I have to specify C slash varchar2. So this is how we can change a string or a this is how we can modify a command if the command is a multi-line command. Okay, looks like the table is already existing. So let me change that to emp underscore temp slash emp underscore temp1. So this is how we'll create a temporary table. Create global temporary table name, column name, column types. After that, on commit, delete rows. So this is a transaction specific table. So for example, if I'm trying to insert into this table, insert into emp underscore temp1 values, okay, now one row is inserted. If I issue commit, once I issue the commit, the transaction is done. So I will not have the content in the table. So if you see here, if I do select star from emp underscore temp1, I will not have any data in the table. The reason is it's a transaction specific table. The moment you issue the commit, the content in the table will be lost. In the same way, if you want to create a session specific temporary table, we'll use the same command, but the only difference will be on commit preserve rows. This will create a session specific temporary table. Now if I'm trying to insert a row into this table, and if I issue the commit, still I will have the data present in the table. So this is the difference between a session specific and a transaction specific temporary tables. Okay. Next, if you want to know information about temporary tables, information about temporary tables will not be present in user underscore tables view. For example, if I do select table underscore name from user underscore tables, okay, sorry, it will be present in user underscore tables, but it will be combined with permanent tables. So if you want to distinguish whether it's a temporary table or not, right now if you see there are 20 tables under Scott user, but you want to know how many tables are temporary tables. In order to know whether it's a temporary table or whether it's a permanent table, there is a column called as temporary in user underscore tables view. This will show you whether a table is temporary or a permanent table. So select table underscore name temporary from user underscore tables. So if you see here, emp underscore temp1 and emp underscore temp, emp underscore temp1 and temp2, even temp, these are the temporary tables which are existing under Scott user. So these are, you can distinguish a permanent table and a temporary table.
Mohan, a small doubt, like What is the use of these temporary tables like?
Yeah.
They-
Yeah. For there will be a requirement where you need to do, for example, you need to fetch information from EMP tables, and then once you get a salary information of EMP, you need to store that into a different table, and you need to do a manipulation in that for that column. For example, once you get the salary, you need to add a commission to that column, and then you need to deliver the salary to the employee. In that case, if you want to do some manipulation of the data, first you will pull the salary information from EMP table. After that, you will add commission to that salary. Then you will
Okay.
store that column into temporary table.
Okay.
Once the salary is issued, again we will issue the commit, and the data in the table will be lost. Just to do some sort of temporary operations, we will use temp tables.
Okay. Yeah, that's-
Any other questions? Any questions?
No, Mohan, that's good.
No more.
Next, whenever you have a primary key constraint or a unique constraint defined on a table, defined on the table, or defined on a column, by default, an index will be created on that column. So first we'll see what is an index. Is anyone on loudspeaker? Is anyone on speaker?
Yeah.
If anyone is on speaker, then I will mute. I mean, like, I'll mute him. Okay, good. So we'll see what is an index. Index is another object in Oracle database which is used for faster data retrieval. For example, if you have a table EMP with 4 columns, and the size of this table is 20 MB. Now, if you want to fetch information about the employees who are located in Texas, say for example, out of this 20 MB of information, altogether there are 2000 employees in this table. Now, the employees who are located in Texas are 100. Now, this 100 employees corresponds to 1 MB of space. Now, if you are trying to fetch employees who are located in Texas, then you need to scan each and every row in the table, and you need to get the rows which corresponds to Texas. That means you need to scan 20 MB of information in order to fetch 100 rows. Instead of that, if you have an index created on that column, for example, location. Now, if I have an index created on that location, and then this location index will have 2 columns. One is value of that location, Texas. Then it will have the addresses of the rows corresponding to the employees who are located in Texas. After that, New York, and then it will have the rows or the addresses corresponding to the rows of the employees who are located in New York. So whenever you have an index, instead of scanning 20 MB of information, first it will go to the index. It will get the records or the addresses corresponding to the employees who are located in Texas, and then it will directly go to that address in order to fetch 1 MB of information. So which makes data retrieval faster, because instead of scanning 20 MB of information, it will just scan probably around 2 MB or 3 MB of information. So for faster retrieval, we will use index, and index is like it's like an index in a book. If you want to go to a specific topic, first you'll refer to the index, and then you'll go to that page number. In the same way, you'll also have indexes in Oracle database, and whenever you're trying to fetch the information, Oracle will use that index to fetch the information. And by using the index, it will make the data retrieval faster. And by default, whenever you have a primary key constraint or unique key constraint defined on a column, an index will be created. So for we'll see, we already defined a unique constraint for audit underscore table. We defined enum to be a primary key constraint. Now, if you want to look at the indexes which are present on this table, you have to go and look that in user underscore indexes. User underscore indexes is the view which will give you the information about indexes. So select index underscore name from user underscore indexes, where table underscore name equal to audit underscore tables. Audit underscore table, because I want to look at the indexes which are present on audit underscore table only. So if you see here, I have an index present on, I have an index which says audit underscore table underscore pk. So whenever you define a primary key constraint, so an index will be created with that constraint name. So when I was adding a primary key constraint, I gave alter table audit underscore table add constraint. Constraint name was audit underscore table underscore pk. With that constraint name, it will create an index. If you don't give a constraint name while you're trying to add a constraint to the table, it will create an index with auto generated index name. Those will be starting with sys. If you gave a constraint, if you gave a name to the constraint, then an index will be created with that name. If not, it will be created with auto generated name. So whatever Oracle generates an auto generated one, it will create an index with that name. Now I have an index created on audit underscore table, but I want to know on which column an index is created. So select index underscore name, comma, column underscore name from user underscore ind underscore columns. This is the view which will show me on which column the index has been created. So if you see here, index is created on enum. This is the way we look at on which column the index is created. Now, apart from auto-generated indexes like the primary key constraint index or unique constraint index, if you want to create a manual, or if you want to create an index on any other column which doesn't have any primary constraint or unique constraint, then the command will be create index, index name on column name, on table name of column name. This is how we will create an index on a table. So if I want to create an index for on column user underscore at for audit underscore table, I will use create index audit underscore table underscore user underscore index on table name of column name. This is the way we will create an index. Okay. So once we create the index, if you want to know on which column the index is created, user underscore it. Okay. Now I want to know table name, index name, as well as on which columns the index is created. Can I know uh, by using which query I can get that information? I already showed you user underscore indexes will show me the table name and index underscore name. But I want to know table name, index name, as well as column name.
Yes, select
Okay.
uh, sorry, one second. Column, what column? Any column name?
I want to get table name, index name, and column name.
Select user underscore AD, the column name.
User underscore AD.
Uh-huh.
It's not like that. The column name will not give the column name. See here, there are two tables or two views called as user underscore tables, user underscore indexes, and
Yes.
three user underscore in underscore columns. Okay, these
Oh,
are called as data dictionary views. They will give you information about the objects which are present in the database. So they contains metadata information, data about data.
data
So
whatever.
okay, now user underscore tables will give me the information about what are the tables exist under that user. User underscore indexes will give me the indexes which are exist under the user, and user underscore in underscore columns will show me the columns on which the indexes are created. Okay, now let me describe user underscore indexes and user underscore in underscore columns, then you'll get a better idea. Okay, this is user in underscore columns. I will remove whatever we doesn't require. Okay, so think these are the columns existing under these two tables. Now I want to get table underscore name, index underscore name, and then column underscore name. So this will show me on which table the indexes are existing and and on which columns the indexes are created. So can you give me a query which will give that information? Any idea?
Directly we'll get the table name, index name, column name from second table, right?
There
DS
is
user underscore in column. Index
Yes,
name, table name.
select star from table name, comma user index table name, and then after column like in the user underscore index underscore column names.
These columns
yes,
are available in
So
correct.
all the table, all the like indexing, all the all the user index column also show.
Yes, correct. So we can just refer to the columns which are presenting and which are present under user underscore in underscore columns to get that information. Yes.
Yeah.
But if I want to get index type also, there is a column called as index underscore type. If I want to get that also, then
join, we can join the table, two tables.
Yes, on which column I should join?
Index name,
Yes, correct. So I'll do select from user underscore indexes.
table name also we have to do, right?
Yes.
Yes.
Oh, I gave it as I. Okay. So if you see here, the data is not, the information is not displayed in a readable format. So you need to set the column size for each and every column. Right now, the table name for that column, it is displayed with probably around 25 characters on a line. For index underscore name, it displayed with 25 characters. But for column underscore name, it is set to 150 characters. So if you want to change how many characters displayed under that column name, we have to use column space column name for A30. That means display 30 characters for the column underscore name. Once we set that, we can go ahead and do this one. So these are how we can set a column size. How much characters needs to be displayed under that column per line. So if I set column name for A30, that means display 30 characters. A means alphabets. So display 30 characters under column underscore name per line. So if it is more than 30 characters, it will be displayed on the second line. Any questions?
Yeah.
So by default, whenever you create an index, it will be B-tree index. So it will be in a format of binary tree. If you have 10, 20, 30 on a specific column, then it will be stored in a format of binary tree. So in binary tree, you will have a rule saying that left, so in a tree you will have a parent node and then left subchild and a right subchild, and the rule will be left subchild value should be less than the parent node and right subchild value should be greater than the parent node. So using that algorithm, it will store the values in a format of binary tree. Now if I want to store 10, 20 and 30, then the order in which the information will be stored will be of this format: 20, 10 and then 30. This is the right subchild and this is the left subchild. So left subchild value should be less than parent node and right subchild value should be greater than the parent node. So by storing the information in this format, whenever it is trying to search a specific information, it will search half of the tree depending upon the value. For example, if you are trying to retrieve an information about the employee whose employee number is 10, instead of searching 3 rows in the index itself, it will just search, first it will go to the parent node, okay, 20 and then the search keyword is 10 is less than 20, so it will go to left subchild. So if you have 100 rows, 50 rows will be eliminated from the search, only 50 rows will be searched. In this way the data retrieval will be faster. So by default, whenever you create an index, it will be a B-tree index. But there are some problems with this kind of binary tree. If you, for example, if you have a column called as male, or sorry, if you have a column called as gender, in that case, you will have just two values. One is male and another is female. If you have 30,000 rows, but the values will be male and female for those 30,000 rows. In that case, the binary tree will not be efficient in order to perform this kind of searches. So instead of going for binary tree, we will go for bitmap index. Whenever there are less number of unique values in a specific column, and if you are trying to create an index on that kind of columns, then you'll create a bitmap index. So to create a bitmap index, the statement will be create bitmap index, then it will be same again. The reason why I'm saying the B tree will not be suitable for this situation is because to store 30,000 values, it has to store first male and female, and then it has to store the 30,000 rows addresses in that index, correct? So it will make the data retrieval little bit slower. So in that cases, if you create a bitmap index, the data retrieval will be faster. So whenever you create a bitmap index, it will be stored in a bitmaps. It will not be stored in a tree format. So you will have first you will have a bitmap pattern. After that, you will have a unique value or a value of the column on which the index is created. After that, it will have the starting address of the row where the value is male. After that, it will have the ending address of the row where unique value ends for male. So it will just search from starting row to the end of the row, depending upon how the values are stored in bitmap pattern. And this bitmap pattern will tell you whether the value male is present or female is present. So this is how we'll create a bitmap index. And if you see here, the index type is normal. So that means it's a B-tree index. If you want to create a bitmap index, for example, create bitmap index on emp underscore 1 of ename. I'm just creating it. Create index. No. emp underscore pm underscore ix on emp1 of ename. Once you have this, if I execute the command again, you will have a different type of index. So if you see here, it's a bitmap index. So by default, whenever you create a normal index, it will be binary tree index. If you want to create a index on a column where there are less number of unique values, in that case, you'll create bitmap index. Okay. Give me 2 seconds. Let me get my charger. Do you guys have any questions till now?
Yeah.
Uh,
No.
what? Mohan sir,
Yeah.
the index are stored in physical location or what? Like create a new physical location,
I didn't get you.
physical storage, right?
I mean, like each and every object will be stored in a physical location.
So like whatever size we have, like 100 MB, 1 GB have a size, right? We have a database 10 GB. So once we create the index, so that they create like a 10 MB take a space for the like a index, store the index value, correct?
It will depend upon how you create an index. If you create an index on all the columns of a table,
Mm-hmm.
for example, if I describe void underscore table,
Uh-huh.
it has 1, 2, 3, 4, 5, 6 columns.
Yes.
Now, if I create an index on this table with these 6 columns,
Okay.
it will be more than the actual table size because it has to store those values including the addresses.
Okay.
So it depends upon how you create an index.
So this called a cluster index, right? Actually.
Why it's called as a cluster index?
So, so means already create like what where once we create index, so it's called a cluster index, right?
It's a general index.
It's a general
It's
normal
a,
index.
it's a normal index which is B-tree index.
So how many like indexing create in a tables like in a column?
What?
How many like index like no like I will create only by primary key only one index in a table, yeah, maybe more like a more all the field have create indexing.
No. We'll not create indexes on all the columns, but apart from primary key index, we will create an index on specific columns depending upon how the data will be retrieved in the application. For example, if you have an application where you are retrieving information about the employees, they may search either with employee name or with location.
Correct.
In that case, we may create an index on ename as well as we may create an index on location such that data retrieval will be faster. But not we'll create an index on rest of the columns because we don't need it. Because creating an index will make the performance better for retrievals. But whenever you're trying to insert a new row or when you're trying to update a new row, it has to update the information into the index also.
Yes. Okay.
In that case, it will be slower.
Okay, so I just one word. Suppose we are creating index, okay, everything done. Okay, after once we are delete like a truncate command, so that time index is gone or what?
No, index will be there, but it will not consume any space because there is nothing in the table, right? So even in the index, you'll not have anything.
So no any effect for the index table and a particular record, right? So like structure is there, but only for remove the data.
Yes, correct. Yes, correct.
The structure is there. Suppose in second time we are insert the data, so automatically they
It
are
will be updated in the index also.
also. Okay. And so once that's okay, fine. So what about like no? I read somewhere like this about the fill factor something. So is there index insert index or what?
Field factor, I have never heard. Maybe you search for a different type of database.
Okay, that's one. Okay.
And then you have another type of index called as function index. Sometimes whenever you are trying to fetch the information from a table, for example, select ename from employee where sum of salary or no. Yeah. Select hire date from EMP where to underscore care of hire date or where hire date equal to 2 underscore char of 16 April 2013. If I'm trying to get information of the employee who is hired on 16th April 2013, and if I'm using any function, whenever I'm using a specific function, by default an index will not be used. So if you have a lot of queries in the application which uses function on a specific column, then you have to create a function based index on that column such that your data retrieval will be faster. Whenever you have a function used on a where clause, then by default a bitmap or bit index will not be used. In that case, you need to create a function based index. In order to create a function based index, we'll use create index one second. So this is how we need to create a function based index. So here we'll specify the function. For example, if you want to go for 2 underscore char, we'll specify 2 underscore char of, then we'll specify the column name which is hire date. Forget about the storage for now. This is how we'll create a function based index. So we'll use function for that column. Then this will be used. This is how a function based index will be created. Okay. For now, you need to know about these kind of indexes: bitmap, btree, and function. There are other type of indexes, but I'll be telling you that in the future classes. Okay. Any questions? If not, I'll wind up the class. I'll continue tomorrow.
Yeah, we'll continue tomorrow.
Yep. Okay then, bye.
Yeah, thank you, Mohan.
Bye Girish.
Bye, bye, good night.
Yeah Ashish.
Mohan sir, Mohan sir.
Yeah Girish.
Yes, yesterday we installed a workstation, correct?
Yes.
So that time the one tool like what our tools, I forgot tools. Those tools used for the like Windows based and this for this based. So those tools not available in a workstation.
What?
Like
In
no
SAP?
the virtual tools. What tools name I forgot the name
No,
actually.
wait. I said VMware tools, okay? Did you saw the
Yes.
video? Did you saw the video? What I said in the video?
Yeah, I saw the video.
What did I say in the video?
The video say like go to the in a property and install the like install
No,
in a
no. Before telling that, what did I say? For what the VMware tools are used?
VMware tools used for like only a two way like the mouse direction,
Yes.
the copy for the some value to the like this one to like a notepad and something that's why we are install the VMware tools.
Yes. But now what is your question?
My question is in workstations they are no available this tool these tools are not so there.
Yesterday we saw it, right? Under VM, I showed it to you. Under VM menu, there is an option called as install VMware tools. Click on that VM.
Oh, VM menu. Okay, I'm sorry. Okay, I forgot actually. Okay, no worry. I'll do.
Okay.
I will do.
Yep.
Okay, thank you, sir.
Yep. Under VM, you have install VMware tools option.
Yeah. Okay. Thanks, sir.
Yeah, Ashish, చెప్పు.
అది ల్యాప్టాప్ నుంచి కనెక్ట్ అవుతున్నా ఇప్పుడు అనిపిస్తుంది అది ఒకసారి.
Okay.